Hi there. I'd like to introduce you to a new resource for solar cell optical modeling called rayflare Lite. It's a full-fledged optical simulation program that can simulate cell and module level thin film stacks, textures, and light trapping using rigorous angular distribution tracing. And you can use it to calculate absorption profiles and thin film layers. And in the substrate, which combined with carrier collection efficiency profiles, you can calculate the photocurrents. So without further ado, let's pull up the program. It's got a cross-section diagram of what would be a typical silicon-based solar cell, and that's sort of the basis. However, you can change it to model different kinds of materials and textures. And then you can define the front layers, rear layers, and then if there's any top cover like glass with coatings, you can also define those, and as well as bottom cover. You can define the spectrum as well as the incident angle, which is default at normal incidence, but you can also change it so that it is at any angular or distribution or lumbertion. To help users quickly get started, you can always select from predefined models. For instance, you can load from any of these examples here. Let's say a perovskite on silicon tandem, which loads the front layers on a texture surface consisting of the perovskite solar cell, which is highlighted in this blue color, and the layers for the bottom silicon cell, which are in red color. And if you click Calc Optics, the Python server will run the simulation. And then very quickly, you will arrive at the absorption currents in the top and bottom subcells. If you hit Calc Currents, then the absorption profiles are further calculated, and based on the carrier collection efficiency of each subcell, then you get corresponding photocurrents in the subcells, which is the fraction of the absorbed photons, which is translated into electron hole pairs that are collected and make it out to the external circuit under short circuit condition. So feel free to browse the other examples as well. For instance, TopCon cell, in which case there's only one subcell, cell 1, which is the silicon cell. And rayflare is a freeware, so feel free to download it from the Griddler website and start using it for your research. So the cool thing is rayflare is also now integrated into the Griddler softwares. If I start Griddler, which now has also an enhanced free version, you'll see that rayflare Lite is on the menu option. So if I load a cell, for instance, TopCon cell, and if I hit rayflare Lite, then I automatically have this TopCon cell loaded if I'm running Griddler. Just as a suggestion, of course, you can feel free to change it to another model or change the optical stack. In this case, there's also a linkage to Griddler so that in Griddler, if you have defined dope regions, those dope regions are also included into the cell model so that the Frey-Care absorption in these layers can be properly calculated. Just as a quick demo, I can hit Calc Optics. And if you're running rayflare from Griddler, it will do steps 1 and 2 combined. So it will calculate first the generation currents, and then it will calculate the photocurrents based on the carrier collection efficiency. So the resultant photocurrent is 41.64 milliamps per centimeter square. That is a result of all these various collection efficiencies in your various layers and the emitter, substrate, silicon oxide, polysilicon. There's also Frey-Care absorption, which is a kind of parasitic absorption, which lowers the photocurrents. And in the end, this current number is translated over in the 1SUN-JL non-shaded area right here. And the corresponding rear incident number is translated over here. So now when you run the IP curve, the short circuit current level is going to be basically this 41.64 milliamps per centimeter square after shading, which comes out to around 39.83 for this particular pattern. So that's a very quick intro of rayflare, as well as its integration into Griddler. Both programs have now very well developed freeware versions available on the Griddler website. Please feel free to try them out and give us some feedback. We hope they will be useful for your solar cell design and analysis. Also, if you have the Pro version of Griddler, you'll be able to access the tandem simulation. And from there, if you launch rayflare Lite, then it will load the tandem model by default. And if you run Calc Optics, and if you click yes here, then it will apply the calculated photocurrents to Griddler tandem subcells. So it will transfer the 18.08 to the top cell and the 2133 to the bottom cell. So if I click yes, okay, so we can see the top cell now has 18.08. And if we go to the bottom cell file, we'll see that it has 21.33. So now if I run the IV curve, it will incorporate these photocurrents. So if you look at the subcell voltages, you'll see that the bottom cell, the silicon solar cell, actually has a higher photocurrent, but because the top cell is limiting the currents, and so it's kind of cut off, and that results in too low photocurrents and very high fill factor. Okay. So rayflare is also integrated into Griddler IBC. So now if I make a IBC cell, you can see here rayflare Lite that will pull up a model of an IBC cell. And being a rear junction device, it's now really critical that the front passivation is good. For instance, if I make the minority carrier lifetime drop down to 1 millisecond instead of 4, you'll see that this number here drops quite a lot. Right, so then now there's less photocurrent to work with in the solar cell. So overall, there is this introduction of rayflare rigorous optical simulation into the various Griddler electrical simulation softwares, which complements the finite element simulations very well. So I hope that this integration will help you advance your research with access to more readily available simulation tools.